You're listening to WMPG 90.9 Gorham, Portland, Southern Maine Community Radio from USM. Live from the Orion Cygnus arm of the Milky Way galaxy, this is Scientifically Speaking, a weekly half-hour program devoted to elegant curiosities, and I am one of your hosts, Sarah Chang, and joining me as always is Bernie Rhyme, DJ Star Watcher. How are you, Bernie?
Yes, hi Sarah, very good, thank you.
Bernie is our professor of the Astronomy Lab at USM and our local protector of the night skies. Reach out to us at WMPG, scientifically speaking, at gmail.com or on Twitter at WMPG-SciSpeak. And you can head over to wmpg.org to find the last 5 weeks of archives of all of your favorite shows, including this one. Bernie, could you let our listeners know what is up in the night sky for this coming week?
Yes, certainly I will, Sarah, thanks. So today will be Friday, October 22nd. So we're going to have a waning gibbous moon. It was just full on the 20th. It was the famous hunter's moon. So we have a waning gibbous moon. It's going to come up around 7. It's not going to set till about 9 in the morning. The sun now comes up around 7 and sets around 5:47. So the days are definitely getting shorter. You can see that. So the moon each night is still going to rise only about 35 minutes later, because it's still somewhat similar to the harvest moon when it only came up less than 30 minutes later. And then you can still see pretty much Venus before sunset. Then if you keep going along the ecliptic, then you'll see Saturn next, and then you'll see Jupiter. Actually, the other night I saw 3 of the planets, Venus, Saturn, Jupiter, and the moon. It was a waxing crescent at that point. So I saw all 4 of them nicely lined up on the ecliptic. And you can kind of see how that angle, the shadow, the angle is kind of shallow, which it does this time of year for the evening for our hemisphere. So you can see all that nicely. And you can look for some meteors. On the 21st, we had the Orionids. So you can still probably see some of those tonight, even though the moon was basically just past full. So lots of things to look for this week.
Awesome. Thanks, Bernie.
Yeah, you're welcome.
And if you couldn't take notes fast enough, you can also check out the monthly What's Up column in the Portland Press Herald. All right, everyone. It is the week you've been waiting for. It's Begathon.
Begathon.
So this is WMPG's fundraising week this week from the 20th to the 26th of October. And you're listening here on the second day, the 22nd of October, because you love listening to us, Scientifically Speaking, on WMPG, talking about science and scientists and kind of cool stuff from amateur scientists in your local community and professional scientists and everything under the scientific umbrella, right? And yes, and we need at least 5 people to call in during our show today. We love that we're able to do this every week for 52 weeks out of the year, and we're hoping that we can count on you to keep WMPG afloat. So call us to tell us that you love listening to us, that we inspire you just a little bit to look at the world with a little bit more curiosity. And like I said, we're here to give you 30 minutes of science and scientists 52 weeks of the year. And, you know, we've cycled through so many interviews of great scientists and citizen scientists and people who just make really cool stuff. And there's a lot of science involved in that here on this station. And we do it because you're out there listening. Bernie, where should our listeners call in right now to make a donation?
Okay, all you need to do is call 874-3000. Very
Sweet.
Easy number to remember.
Yes, 874-3000. And where should they go if they don't want to talk to anybody?
Yeah, so online at wmpg.org.
Sweet. Yeah. So 874-3000 and head to wmpg.org. And you can pledge securely. And we are super excited. So please help us reach our goal of 55K. And what's really cool is if you become a sustaining WMPG donor, we are giving away WMPG Yeti mugs, which is just in time for hot chocolate.
Okay.
All right. So today's show is titled Nobel Begathon. And just very recently, there were the Nobel Prize winners were announced in September. And we wanted to spend some time highlighting those folks and their accomplishments. And Bernie, I think we wanted to start off with the Nobel Prize for Physics. How does that
Yeah,
sound?
physics first. Yep. Hmm.
All right. So there were three Nobel Prize winners.
Hmm.
I actually only have two of them in
Yep, I
front of
got
me
all
right
three.
now. All right, Bernie, you've got all three. Take us
Yep.
away.
Yep.
Who are they?
Okay, so Giorgio Parisi, he's an Italian. Klaus Hustleman, who's German, and Tsukuru Manabe, who's Japanese. And they got it for mathematical modeling of complex systems from the atomic to the planetary scale. So basically, it kind of reinforces a lot of the science behind climate change, but it goes way beyond that. It's just complex systems in general, not just the atmosphere and climate change. They can do water. They could even do systems like the clouds on Jupiter are extremely complex systems. And so they modeled that. Actually, they started doing some of their work quite a while ago, and they just
Yeah,
now the Nobel Prizes for that.
yeah. And they're all pretty old, actually.
Yes, the Japanese is 90, the German is 89, and even the Italian is 73 years old. Yes.
So, Dr. Manabe, the Japanese prize
Hmm.
winner, he one of the things he noted was that there had never been a Nobel recipient for topics in climate change before, which I thought was a little bit surprising, but I guess
Hmm.
that's fair. One of the things that he had noted was he talked a lot about kind of the evolution of how we came to understand climate change and how it's become more of a science. So, as Bernie said, he kind of used a constructed climate model and basically did a numerical experiment, changing one thing at a time to understand how a climate system works. So, how does temperature and rainfall changes? How does that impact massive flooding? Ultimately, he was trying to understand why the flooding and frequent droughts happening all over the world, why those were going on. And so he talks a lot about the pursuit of understanding climate change and that predicting climate change without understanding how it works, basically the science, is no different from a fortune teller. And so,
Yeah.
yeah, some of his history is actually he kind of saw the evolution of how weather forecasting moved from being more of an art, which was kind of forecasting based on hunch and experience,
Mm-hmm.
and moving towards science. So, weather forecasting, how do you do that based upon laws of physics and, how that impacts our daily weather forecasting today? So, very, very cool, very, very cool of the Nobel Prize Committee um, to highlight this area and
Yeah.
have it
Because they
under the
started doing
umbrella
that
of
work way
physics.
back. They were warning us
Yeah.
pretty early, but as you said, it's more of a science now, and it has to be
Hmm.
based on something. That's what they're highlighting now by giving it out now.
Hmm.
Yeah.
Yeah, I mean, we just
Mhm.
recently did the review of the climate change report that came out not too long ago as well,
Yeah.
and that's a lot of
Mm.
basically climate change physics
Mhm.
physicists who've
Yeah.
contributed to our current knowledge and understanding of what is going on here. And
Right.
we can now extract what human contribution is compared to what normal cycles and processes would look like on the grand scheme of things.
Hmm.
um so Dr. Parisi as well, I think one of the things that he talks about that really really says a lot to why I think you and I do this show as well is, and I'm going to quote him here. Well, my mentor, Nicola Cabibo, was usually saying that we should work on a problem only if working on the problem is fun. So, I mean, fun is not very clear what it means, but it's something that we find deeply interesting and that we strongly believe that it is, you know? I mean, you won't find fun in whatever because one gets a new idea of something unexpected, so on. So he talks about how the whole core of why he even pursues doing this is because
Mhm.
it's fun and he enjoys doing it. So
Yeah.
when you listen to them getting called after they learn about them being Nobel Prize winners,
Yeah.
it's, they're really jolly and just
Hmm.
clearly they love doing this. And
Hmm.
that's why we are doing this, because
Yeah.
we enjoy doing this and we want you to call to make a donation to WMPG. So
Hmm.
874-3000, call in. Our volunteer
Hmm.
phone huggers are there waiting in anticipation to talk to you and find out what pledge you are willing to make this time.
Yeah.
What about the other guy? Anything particularly interesting about him? The Klausman guy.
I don't know, Klaus Hustleman. He directs one of the divisions of the Max Planck Institute in Germany, which is like the highest. Several of the other Nobel laureates, run different departments at the Max Planck. I'm not sure what his contribution was specifically to the climate change knowledge. Just his name and kind of where he is. He's probably
Sure.
not teaching there every day anymore at that age.
Well, then let's move on to chemistry
Yep.
and the prizes in 2021. Who were those winners?
Okay, yes. So Benjamin List, a German who actually also teaches at Max Planck Institute, directs one of the divisions, and David Macmillan, who teaches at Princeton, but he's Scottish born and he still has a strong Scottish accent. So, because we were
Oh,
talking about
fair
immigrant
note.
Nobel laureates for immigrants, and though he's Scottish, but he now, of course, lives here and teaches at Princeton.
Hmm.
So it's a kind of obscure thing, but a really important thing in chemistry that they got the prize for. So it's their development of asymmetric organocatalysis. So
Okay, what is that?
that sounds kind of technical, but it's actually super important for especially like medicines and pharmaceuticals, independent of just viruses and things like that. So what it is, normally you need different catalysts for chemical reactions to work, and normally you would use metals or enzymes, which produce amino acids and proteins and all that. But that's not very good for the environment, and it takes a long time. So I was listening to some of the things David Macmillan was saying. He used to work 8 hours a day just to have like one little reaction work when they use these metals and stuff as catalysts, like iron and platinum and stuff like that. And that's very toxic. So now he has organic molecules that can do this work much quicker, much more efficient, and much better for the environment. And it's asymmetric because normally it happens symmetrically, and so a lot of it would be wasted because you can't use the other half of the mirror image. But he figured out how to do it asymmetrically, so just half of it happens, and that's the half he uses to develop like the new drugs or whatever else that they can be used for developing.
Interesting.
Yeah.
And just to clarify, when we talk about organic here, we are
Hmm.
talking about hydrocarbon chains, right? Or anything
Yeah.
that's hydrocarbon
Right. Yeah, like
based.
in organic chemistry.
Mm-hmm.
Yeah.
Mm-hmm.
Because before they used metals to do that, as it's not very
Mm-hmm.
efficient, and enzymes would be organic. But they got the ideas a while ago, and then it kind of worked, and he expanded that, just developing new and more efficient, basically building molecules and so on through these methods, much more efficient. And the neat thing is, he was saying like he would do something in his lab like on a Tuesday, and by Friday, a big pharmaceutical like Merck would be using that to make a better drug for humans to benefit
Hmm.
humans. 3 days later. This is not, no, it's 30 years ago and then it may or may not help us. 3 days later, it's out there and it's being used. So
Very
really
nice.
cutting edge, very efficient, they call it green, a green way to synthesize new molecules and to build them organically.
Huh. Do you have
Yeah.
any numbers on like what it means by green in terms of what we're
Well,
saving as
Well,
far as the
he
metals?
was asked that. I listened to a lecture he gave at Princeton, so he had all these big shots from Princeton asking him stuff, and he didn't even know that it was green per se. He was just looking for better ways of doing stuff. So somebody called it green. No, I don't know numbers. I just know it's a lot faster, and they're not using metals, toxic metals anymore, like iron or platinum, or even enzymes. They're just using. I don't even. I mean, he gave a PowerPoint, and that was way beyond what I could understand of how he really does it. But it's green, it's fast and efficient, and it's better for the planet and it's implemented right away. 3 days later, pretty much right away.
That's crazy.
Yeah.
And
Yep.
then there was another guy, right?
Yes. Benjamin List. He also works at Mac. I don't know what part he. I didn't listen to specific talks by him, so I don't know exactly. But they were independently working on this, so they both kind of got the prize. I'm sure they collaborated too at some point. But
Gotcha.
yeah,
Gotcha.
Princeton and Max Planck in Germany. So
Very
the
cool.
Scottish guy was really good though. I mean, he was very curious as a kid. He told the whole story how he started and got into science. He wanted to be a physicist, but the lecture room was too cold, so he took up organic chemistry instead. Of just really interesting story. His father was a steel worker. His brother was the first person that went to college. So they start from really humble beginnings, and again,
Hmm.
Scotland, Glasgow, and now he's a big shot at Princeton. Nobel laureate, and I'm sure he's going to be wanted around the world now for lectures and continuing his work and all that. So I kind of like when these get some sense of how these people started out too.
Yeah. Speaking of how, awarding the Nobel Prizes.
Yep.
So, when you kind of learn about the Nobel Prize process, it's actually kind of secretive.
Mm.
Um, and the Nobel Prize committee basically requests for nominations, and people are allowed to nominate 1 to 3 people,
Yeah.
and then the committee basically reviews and lets you know that you've been selected as the winner. Alfred Nobel, for whom the Nobel Prize is named after, was really clear in his will when he kind of listed out what the criteria were for the Nobel Prizes in these areas, and those are physiology, medicine, physics, chemistry, literature. What else am I missing?
The Peace Prize.
Oh yeah, and the Peace Prize, yes. But he specifically stated that he was looking for a discovery that would have a benefit to humankind. So their criteria is very, very narrow. They're looking for a discovery that has either opened doors, um, been able to help humans think about a problem in a very new or different way, or there's something that has changed the way we think about a problem. The specific words they use are paradigm shifting. And so the height of the discovery should really be like very, very great. It can't just be I invented something or I've improved something. Like it actually has to be
Yeah.
some kind of discovery, and
Yeah.
then ultimately be a benefit to humankind. And I think, in his own words, those who, during the preceding year, have conferred the greatest benefit to humankind are the ones who deserve the Nobel Prize of that year.
Yep. Makes sense. That's what they're doing.
And just like Alfred Nobel, we love to find those people in our community who are doing great things and are benefiting the world in some way right here in Portland, Maine. So here we are again. Thank you to everyone who's called in, who's given some of that moolah to show us that we are important enough to stay on the air, and to everyone for representing us with those sweet t shirts, those awesome bumper stickers on those sick Maine cars, and the wonderfully whimsical and quirky listeners that are calling 874-3000 right now to make a donation today. And we've got lots of merch that the phone volunteers are happy to go through, and tons of audio love for you right here on WMPG 90.9. Bernie, what do you want to say to our listeners to get them to want to call in to 874-3000?
Well, you summarized it pretty well there. I mean, we are doing all this volunteer, and so we're learning, and hopefully our listeners are learning in the process, so they can support the station a little bit and to keep these type of things going. So it's good for everyone. I mean, greatest benefit, is not Nobel Prize winning quality things we're doing, but they certainly help the benefit.
Yeah, no, we
Yeah.
love finding kind of
Hmm.
those gems in Portland who are just doing really cool things and do just interesting things, and trying to showcase them in the world. And like in April, we don't just stick to pure science. We did a whole thing on poetry and had
Yep.
folks who write poetry about science or observations that they made in the natural world. And so I feel like we kind of are a little broad spectrum here on
Mhm.
Scientifically Speaking. We try to cover a lot of ground and do some different things. So hopefully you enjoy it, and there's a reason why you keep coming back, and why you're calling 874-3000 to make a donation. So Bernie, on that note of conferring the Nobel Prizes to people who have done or made discoveries that have benefited humankind, you had also taken a look at some of those in chemistry and physics in the previous years that
Yeah.
particularly were exciting to you.
Right. Yeah, we did cover some of those before, but it's kind of nice for our listeners to get a history and combine them to see how it works. So for chemistry in 2020, there were two women, and there were only seven women who ever won the Nobel Prize in chemistry. So there were two then. This time there were two men, but 2020. So it was Jennifer Doudna and Emmanuel Charpentier, and they got it for the famous CRISPR-Cas9, the genetic scissors to edit DNA. So that was really perfect timing because that was before they used some of that obviously to develop some of the vaccines and stuff, but this was before really that was an issue. So that's what they got it for. And there's some great interviews with Jennifer, like on Neil deGrasse Tyson's Star Talk that I was listening to. So she'll give you a lot of detail on that, how to do that, which is very critical. And just scratching the surface of any of these technologies. The Nobel laureates that keep saying that they've invented a whole new method that's very beneficial, but they're just barely scratching the surface as to what's possible. And then so 2019, I don't have the names, but these were also people from other countries, and they got it the chemistry for lithium-ion batteries, which are getting more and more important all the time for more and more electric cars and everything. And 2018 was a good year because a woman, Frances Arnold, won the Nobel Prize in Chemistry in 2018. So what she wanted for was directed evolution of enzymes. So I was watching some of her lectures, really amazing stuff. It's almost like we needed to ask these enzymes to do more for us, and they're capable, say, of doing like a million things, and naturally they might do one thing. So if we ask them to do the rest of those million things, we're directing the evolution of the enzymes in real time
Wow.
to produce more things for us that benefit humans or animals or probably maybe even plants or whatever. So just the fact that we could do something at that level, and Frances, I mean, that was just brilliant. I'd love to watch some more things. She highly deserved that prize in chemistry. Just the directed evolution of enzymes. That's just great stuff.
That's very
Yeah,
cool.
yeah,
Yeah. And
yeah.
then what about in physics?
Yeah, physics. So I went back a few years, so some are very interesting there too. So 2020, it was three people about black hole research, the giant 4 million solar mass one at the center of our own galaxy. Again, they've done some of this before, but they just got the prize. So Andrea Getz, she's a teacher, I think, at Berkeley, and I went to she has remote access for her students to one of these telescopes. And Reinhard Genzel from Germany, and the famous Roger Penrose from Cambridge. I mean, he's like 90 now, but he's done amazing things, way beyond just some of the black hole. He actually proved mathematically that a black hole was possible because we've even photographed it, but really didn't know. It could have been something else. It could have been plasma or something. We don't really know what it could have been, but he kind of showed mathematically, Roger Penrose, that the black holes actually exist. And again, I mean, there's millions of them in our own galaxy, so maybe it's not as directly beneficial as a drug or an enzyme, but certainly important for galactic scale and astronomy scales and our general understanding. And in 2019 in physics, I'll go back one more year, that's when the people finally got the Nobel for finding the first exoplanets, which is super important. We did a show on alien life recently. This was discovered back in 1995 in Pegasus. So Didier Cuéllar and Michael Mayer, two people in Switzerland, and then Jim Peebles, a Canadian who teaches at Princeton, they shared the prize in 2019 for exoplanets. So
Very cool.
interesting stuff too, and cosmology and some of the other applications. So
Hmm.
not directly like having a drug in 3 days from now that's better for us, but again, understanding life on other planets, and this could be huge. This could change everything in a bigger scale than just getting a better drug for us.
Yeah, absolutely.
Yeah.
They went out into space for the prize and then came back home for climate change.
Yeah, yeah, right. Climate change and yeah, the whole spectrum, everything's covered.
Exactly.
Yeah,
Um, a little bit more about going back to Alfred Nobel. Now
yeah,
that we've gone through some of the prize winners over the last few years, he was actually kind of the antithesis to what we would what his legacy is, because
yeah,
as I mentioned, he is really looking for those people who have done things and have discovered things of great benefit to humankind. Meanwhile, he is known for dynamite.
yep. Gunpowder, dynamite, all that stuff. Bad, very bad stuff.
Yes, nowhere near as bad as, for example, the atomic bomb, but
Whoa, yeah,
dynamite, he basically developed things that blasted things apart, and a lot of it was to help with construction and things like that. And that was kind of his background. His father was, really pushed engineering, really pushed entrepreneurship, and had worked in construction. And so his dad had also kind of experimented with different techniques for blasting rocks. And you talk about how all these winners are from all these different places. I think Alfred Nobel also really embodied that. I think by the time he was 17, he spoke like 5 languages or something like that: Swedish, Russian, French, English, German. And a lot of that was just because his dad had kind of moved around and kind of sent him off to go learn, I think, chemical engineering in the States and things like that. He was also particularly interested in literature and poetry, which is why we have Nobel Prizes in literature, which is, the topics do seem very disparate, but it's all based on his interest. But he was known for kind of working with nitroglycerin, which is a very highly explosive liquid. And there were a couple of accidents in Sweden with him and his brother. He kind of got forced to no longer be able to produce that in Sweden, and so kind of got pushed out somewhere else to test and experiment. But he started to mass produce nitroglycerin in 1864, and then eventually, was experimenting with a lot of different additives to basically make it more of a paste and could shape it into rods. And that's how he patented dynamite in 1867. And what really changed him, I think, was by the time he was 43, he had worked a lot. He had 355 patents by the time of his death. So he was very skilled in entrepreneurship and basically developing explosives technology. And so by the time he was 43, he was like, oh, I haven't really had much of a life. And so literally he advertised in a newspaper that he was looking for a wealthy, highly educated, or he was looking for a lady of mature age, versed in languages, and to be a secretary and supervisor of household. The last part is a little bit of a dud, but he did meet Countess Bertha Kinsky, who is an Austrian woman, and she kind of was critical of the arms race over time, and she was very famous for a book called Lay Down Your Arms, and ended up being a very prominent figure in the peace movement, and really influenced Alfred Nobel when he basically wrote in his final will that a prize for persons or organizations who promoted peace would be part of the Nobel Prize kind of group, if you will. And so he invented dynamite, things that blew things up, but at the very end of it, things took a turn, and he made this happen. So when he died in Italy in 1896, his will basically said that his fortune would be used for prizes in physics, chemistry, medicine, literature, and peace. And at the time, there were these 2 young engineers who basically helped execute his will, and they formed the Nobel Foundation to take care of the financial assets and start awarding prizes. So very cool stuff. And thank you to our listeners who have called in this past hour. If you wanted to listen to the whole show before calling in, now's your last chance to call in now. Make your donation in our name, 874-3000, or you can go to WMPG to make an online secure donation. Bernie, last Begathon words from you.
Yes, well, again, you covered it well, and if you appreciate programming like this, then you can help us out with that. We're all doing this for volunteer and to learn more things, which everyone needs to keep learning all the time. So That's just one way to do it.
Yes, absolutely. So keep learning, keep listening, and keep grooving to everything here on WMPG. Here are pleas for more donations. And with that, you have been listening to Scientifically Speaking here on WMPG with myself and Bernie. Stay tuned for Something for the Weekend with yours truly, Anella, from 1:30 to 3, and from your favorite nerds. Just a reminder to vaccinate, to mitigate, and then we can all congregate.